Welcome back, everyone. We heard the breakout room was amazing. Everyone was hard at work, and we have a lot of schools that will be ready to present and share and show us what you've done. So excited about that. But first, I want to hand this over to Lauren and two of our amazing college mentors here at ET. We have Catherine and Sanahi, who will lead our Q&A/wrap up.
All right. So Catherine and Sanahi have prepared a wonderful presentation for you guys. And I like to leave this as their time to shine. They are in college right now. So they have this wonderful perspective on studying engineering that you guys should definitely ask them questions about and pick their brains about. You can ask them, what they majored in or what they are majoring in and what their day-to-day looks like. They're wonderful, wonderful resources, not only on this lab, but as life as a will be engineer. And so I will also be available for questions if you guys have any, but I'm going to turn it over to Catherine and Sanahi to share their presentation.
Awesome. Thank you. We're excited to be here with you today. I can go ahead and share my screen. Perfect. Are you guys able to see that?
Yes.
Awesome. Thank you. So we're excited to talk with you about your lab and also, as Lauren was saying, answer any questions that you might have. So Sanahi's going to introduce herself first and talk about her time as an engineer.
Hello, can you hear me?
Yes.
Sorry, my audio was a little off, but hello everyone. My name is Sine Fragoso La Paz. Some of my involvements with Engineering Tomorrow, I've been a mentor as well as a summer intern, and I've also helped with data development for the company. Some of my interests in engineering include biomedical, biotechnology, and as well as renewable energy and sustainable development. I graduated back in May with a bachelor's in environmental engineering from Cornell and currently doing a master's in mechanical engineering. And yeah, so this is a little bit of my engineering timeline and kind of my history with engineering. I was part of a summer math and science honors academy, which is what SMASH stands for at UC Berkeley. And that's where I really learned about engineering skills and maybe what I wanted to do in the future. I also was, when I got to Cornell, I realized I was very interested in environmental engineering and wanted to do more like wastewater treatment. So I joined a project team called Agua Clara, and they kind of focused on providing clean water resources for communities in need. And later on, I realized I kind of wanted to explore the biotechnical, biomedical, pharmaceutical world, and I did a small amount of internships focusing on that. And yeah, they focused on bridging gaps for medical procedures or medical devices. And it was just solving different problems with different devices that they had. And when I realized I finished my bachelor's, I was like, I really like the mechanical aspect of biomedical and biotech. So I decided to pursue the master's and hopefully go into the science industry after. And this is just a little bit of a visual aid. I think there might be an arrow missing if you click one more time. Always does that. But yeah, the left corner, you can see I did a lot of group projects, a lot of presentations during high school, and that led me to Agua Clara, which is what I called. And what you see me hugging there it's called the upflow anaerobic sludge blanket, which is part of the wastewater treatment plant back in Ithaca, which is where Cornell is. But we helped manufacture a second one to kind of alleviate the stress from just having one. And afterwards, I just did a bunch of mechanical design, as you can see, kind of in the middle bottom of a mechanical device, and that was meant to grip tendon, so mice tendon, and you can kind of see in the middle an actual tendon of a mice. And yeah, for fun, I'm part of some dance teams, so that's what you can see on the bottom left.
Awesome, thank you. I can go ahead and introduce myself as well. My name is Catherine Zinkin. I'm a senior at the University of Notre Dame studying chemical engineering with minors in energy studies and engineering corporate practice, which is more about the business side of engineering. Within engineering, I've definitely been discovering my interests over time, but I'm really interested in renewable energy, but also the bio side of engineering in pharmaceuticals and medical devices. So here's a little bit about my journey in engineering. So in high school, I definitely did not know I wanted to be an engineer. No one in my family was an engineer, and to be honest, I didn't really know what an engineer was. But I took math and science courses that my high school offered, such as biology, chemistry, physics, and calculus. And through that, I decided to start college as a mechanical engineer without, again, knowing much about what it was. I got to Notre Dame, and in my introduction to engineering course, we had the opportunity to look at a lot of different types of engineering, and through that, and talking to professors and upperclassmen, I learned that my interests were more aligned with chemical engineering. So I switched my major partway through freshman year, probably. So I was able to register sophomore year for those chemical engineering courses. So my sophomore year, I got more into chemical engineering and joined a research lab. So I started studying lithium sulfur batteries and more about renewable energy. And I also studied abroad in London, and through that worked at a carbon capture plant, which was a great hands-on industry experience and learning what it was really like to be in a plant. My junior year, I continued my research in batteries, but also became a lot more interested in bioengineering. So this past summer, I interned at Merck, which is a pharmaceutical company. And through that internship, I was able to pair my interest in pharmaceuticals with sustainability and worked on some projects increasing the sustainability at Merck. And then this year, I'm continuing the battery research. And after really enjoying my internship, I'll be returning to Merck to work in pharmaceuticals after graduation. And then here's some pictures of my time engineering. So the top pictures are me working in my lab. The film you can see in the middle is one of the films we've made to put in batteries to try and increase their rechargeability. In the bottom left is my classmates at the carbon capture plant, which again was just a cool opportunity to put on our lab coats and really see what industry would be like. And then I included a picture. I play the saxophone, so that's one of the things that I like to do for fun outside of engineering. And yeah, so we'd love to, I can stop sharing my screen, but we'd love to hear about your lab or answer any questions that you might have.
So this is your time. Teachers and students, feel free to pop your questions for Lauren, Catherine, or Sanahi in the chat, or turn on your mics and ask any questions that you have. It can be about the lab or, college and career pathways. And while we
Sorry, Jillian. For organization, if you guys are going to turn on your mics, please raise your hand so that we can just go in order, just so that we don't have multiple classes talking at once. Sorry to.
No, absolutely. Anytime. I will start us off with the question, and then again, teachers, students, throw your questions in chat, okay? So one question that came through before the lab was, and Lauren touched on this one, but is the water that we clean in the lab drinkable? And what if we test it for bacteria before we drink it? And that was from Montville Township High School in New Jersey.
Yeah, I can talk. I know Pilgrim High School is their hand raised, but I can talk a little bit about if it's drinkable. I wouldn't say it's fully drinkable. I think there's a lot more processes that it has to go through. And I know you guys kind of mixed some things and you kind of filtrated some things. So this is just like a small scale of what I guess wastewater treatment does, like cleaning your water. So I would say in the grand scheme of things, no, but it is like a small scale if you think about it, a wastewater treatment plant. So I wouldn't say it's like the worst thing to drink, but I wouldn't suggest it at all. I know the other question was I forgot I'm so sorry. What was the next question?
Okay, it was just, what if we test for bacteria before we drink it? Yeah.
Yeah, so I mean, yeah, you could definitely test it. I think it depends also the materials you're using. So maybe if we didn't wash hands or if like some material got like a little infected, I feel like it never hurts to test it. But yeah, I see Pilgrim High School has their hand raised. Do you guys have a question?
Yeah, so you're in an engineering major, correct? Or you were, sorry.
Yeah.
So was it difficult? Like, were you intimidated? Because I know it's a lot of math, like heavy stuff. So was it difficult to decide? Because I know, like, I see like a lot of videos and like on social media and stuff about engineers like just not liking their college experience. Mainly because it was so difficult. So I'm just wondering, like, how was that for you? Like going into college, were you intimidated by the engineering path? Like how did that, like how
Yeah,
did that?
great question. Yeah, Catherine, do you want to jump in and I can go after?
Yeah, sounds great. So I definitely was intimidated starting college. Some of the classes, like full transparency, some of them are really challenging, but I've noticed that being in engineering, there's a great support system. So my classmates, my professors, other students, other like upperclassmen have always been more than willing to help. So I've learned a lot about just asking for help when you need it. And people are more than willing to take the time to make sure you understand it. So it's definitely been a super collaborative environment. And also I have definitely had time to do other things I've enjoyed, such as the marching band. I have on-campus jobs and being involved in labs. So yes, the courses are challenging, but I definitely think it's manageable, especially with a good support system.
Yeah, I will say just to jump off of that, I feel like personally for me, the classes were really difficult, but just know like those sometimes most of the time those math and science courses are to like weed out people, unfortunately, like people that might not know if they want to do engineering. So I would say like if you really want to do engineering, just stick through it. Like I feel like this is the case for most people, but my first exam was really, really low. Like I think like it was just really bad grade, and everyone gets a bad grade, but don't let that discourage you. Definitely, as Catherine said, it's a very collaborative environment. I think, as I mentioned, like I started environmental, and then after my bachelor's, I was like, wait, that's kind of not what I want to focus on. So it's definitely a journey. Just stick with people, that you can trust and work with, and go to office hours. There's a lot of resources out there for you.
And I just want to point out for that question, there are so many different kinds of engineering. And so say math isn't your strong suit, you'll have to take all those basic level classes, but there are actually kinds of engineering that aren't super math heavy. And if you really want to do engineering, you can kind of focus on those. And personally, I'm very bad at biology. So I knew that biomed was not the way to go, and marine biology was personally not something that I could do. So I am good at math, and I went towards like those math heavy courses like fluid dynamics, and that was something that worked for me. So finding what works for you is super, super important, and knowing that there's flexibility.
Absolutely. Thank you to that young man at Pilgrim High School. How dare you eat pizza in front of all of us? But thank you for that question. I do have another one. And Lauren, you spoke a little about chemistry earlier. This is from Notre Dame High School in California. How is knowledge of chemistry helpful for engineering clean water designs? How is chemistry helpful?
Yeah, I can speak a little bit about it. Chemistry, I feel like especially with what you saw at the picture I showed about the upflow anaerobic sludge blanket, we use a lot of chemistry to make sure that the water is being cleaned. So we go through the whole process. We look at making sure, this might be a lot of gibberish right now, but for example, like if the water is converting to methane correctly and that it's being, you know, that it's being burned to CO2 and all of that. So it's very much of a kind of process, a linear process that chemistry helps you with water, specifically with wastewater treatment. Um, and also, it doesn't just pertain to water, it also might pertain to air pollution, to renewable energy. So it's a lot about, I guess, like how you start. So what type of chemicals you start with, you mix in that water, and what the process looks through, kind of what the outputs might be when you're treating it. So it's definitely a lot of chemical reactions, I would say, that you have to learn, and balancing equations. At least that's what I've seen, yeah.
Awesome. Okay. Any other questions? I'm checking the chat. And if not, I can ask one more general question, and then Lauren, we can see if any schools are ready to share with us and kind of transition into our wrap up.
That sounds great.
Okay, so for Catherine and Sanahi, any advice for these scholars on the call today as far as figuring out their strong suits and what they may want to major in and deciding on college? I know it's a big question, but any advice, that you would give them?
Yeah, I could go first. I guess I honestly think you fully don't need to know what you want to do after graduation. I've changed my mind so many times. I was like, oh, I want to be like biomedical engineer, I want to be a bioengineer. So definitely don't get too frustrated. I feel like the first few years you literally just take general ed courses either way. So just focus on those and then kind of involve yourself in either, like Catherine said, she was part of labs, or if you want to join a project team or an internship, that's your opportunity to kind of test the waters a bit.
Yeah, that's great advice. And building off of that, I would say not getting too worried early on in college about what you want to do at the end of schools. Because again, for me, I had no idea when I was a freshman, but just making sure you're following your interests. And for me, actually, a big part of what got me into chemical engineering was my high school job. I was a baker, and learning about the chemistry of food was actually a big part of what got me into chemical engineering. And so just following your interests can help you develop new interests as well. And also just being persistent. There are tough classes and tough projects, but knowing that you're smart and hardworking and you can do it, even when classes can be tough, and reaching out to others for help as well.
I love that. That was really, really good advice they just gave you guys. Lauren, what do you think? Should we see if we have any volunteers to come up
Yeah.
and show us
So we
some?
had a lot of sharing in the breakout room, but I know we didn't get to everybody. So same system. If you guys want to share, just throw up your hand in the Zoom room, and we'll just go in order of whose hand comes up first. I know that there were a lot of really excited schools, so don't be shy now just because we're in the main room. You guys all wanted to share just
I
15 minutes
know.
ago.
I saw some screenshots, so I know they were hard at work. I saw Edmonson County, which is in Kentucky, and I saw, who we should go to? Stone Ridge, because we
They
actually
had a lot of enthusiastic
and we
students.
have
Yeah.
some PT family there. We have one of our engineers, Joanna Cotto, there. Stone Ridge, are you able to turn on your camera and talk to us? And while we wait, again, a big thank you to Sanahi and Catherine. You guys did an awesome job leading that Q&A. Really appreciate you guys. Let's see if we can get Stone Ridge, but in the meantime, anyone, you can turn on your camera, come on up and show us what you did with those filtration systems.
Yeah, you guys already got to pick Ariana's brain, but here are two new college mentors' brains to pick about your designs. So you guys weren't able to see them, Catherine and Sinai, but they had some really great designs, and I'm excited to hear what you guys think about them.
Same. I saw pictures of Catalina Foothills High School in Arizona, hard at work. Anyone want to talk to us? We don't bite, we won't embarrass anyone. We just want to see what you came up with.
Yeah, if anyone has any, I guess, what they thought was interesting or what was challenging.
Maybe you got Catalina. Yeah.
Oh, yay.
Let me spotlight you
Oh,
guys.
is it on?
It's on, yeah.
Oh, hi. Wait, I have it written. This is what we got, and this is what we started from. What did we do? We put tissues and then sand, and then we didn't have any more cotton balls, so we bunched up more tissue, and then we did rock, and then like another layer of tissue on top.
Wow, that's a big difference. Like, Lauren, look at that dirty water before.
Yeah, what would you guys say on the scale? What NTU is your water? Sorry to put you on the spot. If you guys haven't reached that, it's fine.
5.
Yeah.
Okay.
Nice, nice. Good problem solving using more cotton tissues is definitely, I'm pretty sure that made the difference.
Excellent job, ladies. Is there anything you would do differently next time?
Oh.
She said no, get me off
guys
the screen.
They got shy. Thank you.
That's okay.
Thank you.
That was an awesome design though, and especially sometimes in engineering you don't have all the materials you expected, and so being able to problem solve and work with the materials you had is really awesome. Great job.
That was
For
awesome.
sure.
Thank you to
Mr.
Catalina High School for being brave and showing us your design. Anyone else want to pick Catherine and Sanahi's brains? I mean, they're wonderful, wonderful resources.
Mr. Lee usually has a group that will show us something. Are you guys still working? It looks like they're still working.
I know they're California, so they might have literally just gotten into school.
True, true. Pilgrim High School? Hi. Come show us something.
Oh, I see Lutheran,
Mhm.
Iowa. I think they moved their camp.
Just put a note in.
We're starting our second one now.
Awesome. How was the first one?
It was all right. It wasn't the best, so that's why we're trying it a different now. We're making thinner layers.
So what about the first one worked? What was the result? And what are you changing besides the thinner layers?
We're adding less sand and like more gravel to like separate the dust and the cinnamon and whatever, and we're gonna add more like cotton balls and stuff in between. But yeah.
Good job. Sanahi, Catherine, any comments on that thought process?
I'm just gonna say great. I wouldn't have thought of that, so that's very great thinking, guys.
Awesome. And
Awesome
maybe
job.
we'll talk to them again after the second round. I do see we've got Iowa and we've got Stone Ridge as well. And that is where ET engineer Joanna Cottle is. So Lauren, you decide who we go to first.
Let's go to Iowa. I saw their hand up first, so
Okay.
just order of hands.
All right. Our design was coffee filters and then cotton balls, and then coffee filter and then cotton ball. And then we put gravel, then sand, and
Yeah, that
that's
was
the final product.
pretty clear, guys.
Yeah,
You can like kind of see through the bottle. That sounds great.
that's looking like some Fiji water. You guys did really good.
Yeah, it looks so
Yep.
clean.
How did you guys decide which order to put the materials?
I don't know. I kind of just went off of whatever I thought of first.
Feeling, yeah.
And
That's great.
is that your first design, or have you made more before this?
Oh, this is our first design.
If you were to change anything, is there anything you can think of to change? If you
No,
were
I'm pretty happy with the final product.
Yeah,
Fair enough. It looks
good.
very
Great
clear.
job, guys.
Ariana and I were blown away with how clear their water was in the breakout room. I mean, it's a really impressive design.
It really is. Kudos to you guys.
Yeah,
Thank
great
Thank you
work.
again for sharing with the big room.
Appreciate
Not
it.
that clear. There's
All right, let's go to Stonebridge. Let me pin you guys. Look at that energy. Talk to us. Unmute. Talk to us.
So here's our water filter.
Nice.
Oh wow.
What did you, what materials?
So do you have any questions?
Oh, I was just gonna say, what materials did you guys use? But I think you guys were gonna answer it.
We used cotton balls, sand, rocks, and water in a coffee filter. And we went in the order from least dense to most dense, and then we added our water in.
Oh, wait, that's a great thinking process. Do you guys think, did you guys find any part difficult or anything that you would change?
Not really. No.
Yeah.
It's
No,
hard.
I
like
like
a
how it's very condensed, very, yeah, it looks great.
I love the giggles too.
Thank you. Thank you. Have a great day, everyone.
Thank you.
Y'all did amazing.
All right, who's up next? Did I see? I thought I saw a hand. Was it Samuel Clemens High School?
I think Pilgrim
No,
High School
okay.
hand up.
Pilgrim does?
Yeah.
Oh, maybe they finished the second one. Let's pin you guys. Talk to us.
No, we didn't finish our second one, but I was just wondering if you could if you could actually make one, what order would you put it in?
Oh.
Good one.
Good. All right.
What?
Yeah, did you guys get that question? That was a good question. Said, what order would you guys do it in, Sanahi and Catherine?
I can show mine. I made one. This is the first one I've ever made, but
That was really good.
I put the coffee filters at the bottom and then the cotton balls and then, or sorry, I did coffee filters, sand, cotton balls, and then rocks. And my thinking was trying to separate out the bigger particles first and then putting the finer materials at the bottom. My water didn't, I dumped out some of it, but it didn't work super well. But I think that some of that was from the dust on the rocks. So I'm planning to try again and clean off the rocks before I put them through the filter in the filter next time. But that was my design. So Nahi, what would you do in yours?
Yeah, so I don't have mine right now because it actually got tipped over by my dog. But I did write the order. But yeah, kind of similar to Catherine. I did the rocks and then I did the coffee filter under. I put two coffee filters, that was being a little extra, but I did that and then I put the sand and then I put a little bit more rocks and then a coffee filter. So I kind of did like a sandwich method. It was just for experimental purposes, but I would say it was like a level maybe 6. It wasn't too clear, so very impressive that I saw so many clear designs. Engineering is all about experimentation, so I think you guys are doing a great job. The fact that it's like your first time.
Yeah, absolutely. And I love that. I don't know that I've ever heard the question like, mentors, how would you do this? So I love
Yeah,
that.
great one.
Right? Any other volunteers? Okay. I thought Mr. Lee was coming over. No? Okay. If not, I can throw you another question that was submitted. Is that okay? Let's go with, where does drinking water come from? Can we drink rainwater? And that came from Iowa, the school that we have here today. Yep.
Yeah, I guess so. Yeah, drinking water usually comes from a nearby. It depends, like obviously where you're located, but it comes from like a nearby water body. So, for example, for where I'm from originally, I'm from the Bay in California. So sometimes they use it from reservoirs or they use it from nearby lakes, and they take that water and put it into a nearby wastewater treatment plant. Essentially, that treatment plant has like big basins, so like big I guess like containers that like collect the water. And then there's a lot of steps which I won't go through in detail, but there's definitely a large line of making sure you chemically clean the water. After you chemically clean the water, you want to make sure you take all of the, I guess like big things in the water. So and anything from like plastic water bottles, from I guess like paper, anything that may be big, and then also clean it through fine, I guess, filters, and that makes sure that any sedimentation is being cleared, and you just kind of go through the process. And it wastewater treatment plants are usually big, so there are a lot of things that go on there. But yeah, it just usually comes from like a body water. I don't know if Catherine, you have more to add.
Yeah, that was a great response. So it's interesting because it's just depends on where you come from. So in my hometown, we have a lake, but where I used to live, we actually had springs. So we didn't even use water treatment because we got water from springs like pretty far underground. So the level at which you treat the water also just depends on the source, and what kind of minerals and contaminants are in there.
Yeah,
And
I know
I
there's
just want to add about the rainwater aspect. Rainwater is really just evaporated water from any source of body or body of water around us. So it can be from the ocean, lakes, rivers, if the water is still enough in some areas. And so it's just the water cycle, which you guys all learned in elementary school. It all comes back to the water cycle. And the evaporation process will only take up like water. So it might be water contaminated with bacteria and other kinds of minerals, but for example, the salt in the ocean, that will stay at the surface while the water component actually is the part that's evaporated. So for the most part, rainwater is what we use to start the water filtration process. So it becomes that fresh water that we use, and then we disinfect it and we filter it, et cetera, et cetera. Another really important aspect about rainwater is that it's also got higher acidity than the water around us, because there's a lot of CO2 in the atmosphere, and CO2 is actually acidic. It's what we put in our sodas to make them fizzy. And so it's got some acidity that also has to be treated when the water filtration process happens. And so there's just a lot of different naturally occurring chemicals that get involved and bond with that water. And that's why water treatment is so important, because too much CO2, just like drinking too much soda, can actually be really bad for our teeth. The acidity wears down into our enamel. And so there are just a lot of different kinds of natural chemicals that occur that we want to often filter out or even add. We add fluoride to water. I know that was one of the questions. We add fluoride to water to actually strengthen our teeth. Fluoride is really good for our teeth and our enamel surface, and it's a good mineral to have in our bodies. It strengthens our immune system. So adding or subtracting elements and minerals is a huge part of water filtration.
Perfect. I think they will be very pleased with those answers. Thank you for answering thoroughly. Catherine and Sanahi, if you had any more slides you wanted to share, we could throw it back to you. And teachers, again, if you want to hop in, you have a group that wants to share, just kind of raise a hand. We will definitely spotlight you. But I'll throw it back to you, ladies. We still have a few more minutes before we present our speakers for today.
Awesome, thank you. And yeah, if you have any more questions or any designs that you want to show us, we'd be happy to answer those or give feedback on your designs. So next, we just wanted to talk a little bit about the materials needed for desalination. So one idea of getting more fresh water is having water evaporate, and then collecting that water, but there's salt and minerals. And so it's important to think about the resources we have. So desalinating water is expensive and does take a lot of, as you can see, energy and resources. So that's just an important consideration when you're making a design, is just thinking about the costs and resources that you have available.
Yeah, and I can talk a little
Go
bit
ahead.
about the overusing aquifers. So as any, I guess, environmental resource, if you do overuse it, it could kind of, contribute to an increase of CO2 and also just global warming in general. So if also just with any body of water, but if you are overusing aquifers, that can also just decrease the amount of water that's available for nearby plants, but also nearby like animals that might need it. And I've had also as I said, I'm from the Bay in California, but I've had reservoirs nearby that have been overused, and now they're just dry. There's nothing there. So there's definitely a danger regarding kind of overusage, and it could also increase the amount of dry soil nearby, and that could lead to so many other different I guess dangers. So that could increase the I guess the or I'm trying to use the right word, but it could increase kind of the traveling if there are, fires. If it's really, really dry, it might also kind of danger the ecosystem of an animal. So there's definitely different things that you should think about when you're using a natural resource.
Awesome. And then we wanted to talk a little bit about the different career paths that you can take with water treatment. So most of you guys are in high school now, and with your high school diploma, you can do things such as being a manual operator. If more education is something you're interested in, you can do a 2-year program to be an engineer technician. Or if you're interested in a 4-year college or university, you can be an environmental engineer or a hydrologist. And then a lot of people who want to go deeper into their field, learning about it, they will go to graduate school. So you can do a PhD and be a doctor of environmental science, or a senior engineer or senior project manager through a master's of engineering. So there's just lots of different options if water treatment is something that you're interested in.
Yeah. And I guess to talk a little bit about more civil and environmental. So a lot of the times, civil and environmental are kind of grouped together. Specifically for Cornell, we have the civil and environmental school. So we those groups are just very similar, just because they do a lot of renewable energy and just encompass a lot of the same things. But there are some organizations that you guys can get involved that are very, very important in towards networking, as well as like learning different specialties. So there's NSBE, also known as the National Society of Black Engineers. There's SHPE, which is the Society of Hispanic Engineers. So those are kind of just cultural-based organizations. And there's also Society of Women Engineers, and there's specific societies for that specific major. So the American Society of Civil Engineers. And what all these societies do, they introduce you to professionals. So for SHPE, I've been part of SHPE, and they've brought in professionals, talk about their field. And it doesn't only have to be about civil and environmental, but just a great way to kind of get exposure about the field and know what different projects may look like when you're in the field. So definitely a great resource to get involved. There's also a lot of internship and job opportunities we would suggest. So if you think you want to do civil environmental things, internships are a great way to kind of get that exposure and make sure, is this something I kind of want to do? There's Langan, there's the EPA, which is the Environmental Protection Agency of the US. They do a lot of environmental work. There's Clark Construction, which is kind of more civil. Um, there's Jacobs Engineering, so they do have a lot of projects. And mind you, they're not only civil and environmental, they have other things too, but these are a great way to kind of get that exposure and get kind of to see if that's what you want to do in the future.
And then we wanted to highlight some of the skills that you've gained throughout this lab. So you've learned a lot about the importance of having clean water in everyday life, as well as the job responsibilities of an environmental and civil engineer as well. You've learned a lot about how to use the engineering process to design a water filter and making iterations after having things that you'd want to change in your project, which is a big part of engineering. And then also the fundamentals of water treatment, which is super important in everyday life.
Yeah, and from what you learned from the lab, there are some topics that you guys could explore more. There's osmosis and reverse osmosis. There's Stokes' law. There's clarified design. The social impact of clean water. So that could just include, you know, how the health impacts, but also like socially in your community, which I think is a very interesting topic. There's fluid dynamics also, which is like kind of literally just in the name, how I guess the dynamics of a flow, so a fluid. So that just kind of shows you like how things move, as well as water move, and that's kind of used in wastewater treatment plant as well. Some other interests you could do clean water in are obviously environmental, chemical, mechanical. Mechanical could encompass kind of working in wastewater treatment plants, seeing how you could build or maximize the space there. Civil engineering, there's also water engineering. And yeah, these are not only some of them, but kind of the overarching view of what you could do with clean water. There's also remediation that you can do, and that's a specific field in environmental. So there's definitely a lot of opportunities for people that want to do clean water work. And yeah.
Awesome. And then we just wanted to talk a lot about, or a little bit about the engineering process. So whenever you're doing an engineering project, there's a lot of important components. So you can see designing what you're building, testing it, so validating and making sure that it works, and then testing and using different tools to image those tests. And then you can look at your results and conclusions to analyze whether it had the intended impact, and if not, going back to your design and making those changes. So it's definitely an iterative process, and a lot of times things don't work out the first time, the first idea. So going back and analyzing those results is super important.
Yeah, and I can, I guess, sorry to go a little bit back, but just speak a little bit about the this project that you see. So to kind of take it back to like clean water. So when you're designing something, you could design something like anaerobic sludge blanket, which is what I mentioned before. And when you validate it, you want to take, data. So that's what you see, the charts, the data, everything. You want to make sure that it's going as it's supposed to, what it's supposed to do. And that's when you start testing. So imaging is just part of this project, just because in this specific project, I had to image attendant, but in maybe clean water, you would image kind of how clean the water comes out or how much methane is being produced in. There's machines that kind of collect it and kind of tell you from the pressure how much methane there is. And from results and conclusions, that's just, you could see how clean is it, how much methane is being produced, but also, I guess, like how many resources I used throughout the whole project and also after results and conclusions, you kind of, this is just a loop. So you kind of go back and you're like, what can I improve? What can I make more efficient? How can I reduce costs? That's always a thing in engineering. How can I reduce costs but increase efficiency too? So that's definitely just a little overview of what it might look like for sure.
Thank you guys so much. I told you that these mentors were brilliant, and this can be you guys in a few years. I want to thank you, Sanahi and Catherine. That was absolutely amazing. Thank you so much.
Thank you. And it was great to see all of your designs as well. They looked awesome.
Yeah, I learned a lot. So thank you for everyone that shared.
I did too. Well, Lauren, I think it's time. I'll pass it to you to introduce not one, not two, but three amazing engineers to speak with us today.
Yeah, we have a fantastic lineup here for you guys today. So if you've heard of the Society Engineers Without Borders, we've got 3 engineers from Engineers Without Borders here to talk to you about clean water and the filtration process and implementing that filtration process, not only in our country, but around the world. They've got some international expertise that they're going to share with you, which I think is so, so cool. So they've got a whole presentation lined up. They're going to talk to you guys about all of their experiences pertaining to clean water and not pertaining to clean water, pertaining to any experience they've had as a professional engineer. And then we're gonna come back to the main room and kind of do a little bit of a Q&A. So think of your questions as they're presenting, write them down, and then if the teachers could throw them in chat and we could have our 3 wonderful engineers answer them and do a little bit of a Q&A session. But without further ado, I want to introduce Melissa Montgomery, Natalie Selmo, and Brooke Poppy, and Melissa is going to take it away.
Thank you so much. I'm so excited to be here. Really, really excited to talk to you all today and share a little bit about our personal stories and our work. We'll start off with some brief introductions. So I'm Melissa Montgomery, and I have the privilege of getting to lead all of our programming here at EWB USA, specifically on the international side. I'm an engineer. I'm a registered professional engineer in Colorado, which is where I live now, but also in Florida. And I studied engineering. I got my undergrad and my graduate degree in engineering. My master's degree was in agricultural and biological engineering. And I've been working for EWB. Gosh, this is my 11th year, and I still think I have the best job. It's really great to be here. Thanks again. And I'm going to hand it over to Brooke for her introduction.
Awesome. Hi, everyone. My name is Brooke Poppy. I am a senior program engineer for Engineers Without Borders USA, where I work for our community engineering core program, which we're going to talk a little bit about today. It's the work that we do here domestically in the US. I graduated from Purdue with a degree in environmental and ecological engineering. And after I graduated, I started working for a traditional civil consulting firm doing sustainable site development in stormwater management with green infrastructure design. But I moved over to the nonprofit world around 2 years ago when I joined EWB USA and have been loving it so far. So it's so great to meet with you all today, and I'll pass it over to Natalie.
Thanks, Brooke. Hi, everyone. It's so great to meet you. If you couldn't tell, Brooke and I are in the same room, which is why the audio is coming from my computer. My name is Natalie Selmo, and I am also a program engineer at Engineers Without Borders. I got my start at Engineers Without Borders as a student at the University of Pittsburgh back in 2011. And I graduated from the University of Pittsburgh with a civil and environmental degree, and then went into the construction industry for a little bit before transitioning to working at Engineers Without Borders for the past 5 years now. Like Melissa, it's very much, I think it's the best job. It's a dream job for me. And I'm really excited to share a little bit more with you all about how I got here. So to get started, like Melissa said, we're really excited to share with you all our pathways to engineering and what excites us about being in engineering and what continues to inspire us and motivate us to be engineers. But before we tell you a little bit more about ourselves and our pathways to our career, we're going to share a little bit about the Engineers Without Borders organization and the work that we do. So here at Engineers Without Borders, which is EWB for short, we practice community engineering. So what is community engineering? Community engineering means that we partner with communities throughout the world and here in the United States who lack access to basic infrastructure. These communities often face inequities due to their economic status, their race, and otherwise can't afford or access engineering services. So these are communities that live without access to drinking water, that live without access to bridges to cross rivers to get to their schools. And as an organization, we partner with them. So all of these projects are driven by the community. They are all community centered. And we are a volunteer organization, which is really exciting because we partner with these communities with volunteers. Like I got my start in college. And while these volunteers are working with these communities, both the volunteers and the communities are growing as global leaders in the engineering field. So while we are improving the basic infrastructure of these communities, we're also enhancing engineer skill sets around the world, which is
I think it froze for just a second. Melissa, are you there?
I think all three of them might have been dropped because Melissa just entered the waiting room.
Oh, okay.
And I don't see Brooke either. So bear with us, guys. One
Bear
second.
with us. It's all right. Always something with technology, but that's all right. We'll get right back on.
All right, there's Melissa.
It's Melissa, okay.
Hi, I'm sorry, I don't know what happened.
You're back.
Okay.
Hello, I'm so sorry. Can you guys hear us?
Yes.
I'm not sure what happened. I think we might have gotten kicked out of the internet. Okay, I'll pick up right back. So back to Engineers Without Borders. These are the great partnerships that we have all around the world. We've partnered with over 1,000 different communities in 60 countries and 33 US states and territories. And you'll see in the top right corner here, this is an overview of our project types. So very relevant to our lab today, more than half of our projects have been in water supply. So water supply meaning that we are providing and working with communities to access clean water, clean drinking water, so that they can use not only to drink, but for their everyday activities.
Awesome. So we want to start our discussion today just by sharing some stats that motivate us to do the work that we do. So globally, there are 2.2 billion people in the world that lack access to clean running water. More than that, 3.5 billion people lack adequate sanitation. And these numbers come from the UN's World Development Report, which was published in 2024. So this is pretty recent data that we have. And just to put this in perspective a little bit, it means that nearly a quarter of the global population does not have access to clean water in their homes and also sanitation services. And when we think of these water challenges, we often associate them with low and middle income countries, but the truth is that there's a lot of people in the United States who are facing this challenge as well. Recent studies show that there are over 2 million Americans who lack access to safe water and sanitation. And by safe water and sanitation, we mean basic running water in their homes and indoor plumbing and running toilets. This is the best data that we have for now, but we think this is a really conservative number and that there are likely many more, people across the world and in the United States who are lacking that access. And we also know that communities of color are disproportionately impacted, and that Native American households are 19 times more likely than white households to lack access to basic water and sanitation services. And more than that, there are 44 million people in the United States who are served by a community water system that has violated the Safe Drinking Water Act. And that's EPA's way of protecting water quality in the United States. And so 44 million people across the US drinking water from sources that have violations with the EPA. And so again, just these numbers to kind of put it in perspective and share a little bit about the scale of the challenges that we're seeing across the world and here in the United States as well. And then we're going to dive into some stories.
Excellent. So I'm happy and excited to share the first story with you all. And the story is about a community called Chaquilla, and it's located in Guatemala, in the Sololá region, which is a little bit in the central region of Guatemala. And in these photos, you can see two things. On the right, you see the water committee in front of the project that was the water system that was built for this community. And on the left, I wanted to highlight and share a little bit more about one of the women leaders that I was inspired by. I've had the opportunity to visit this community a couple of times, and her name is Maria Tok. And you can see her on the left, along with one of her daughters. And I really love this photo on the left because this is at the community celebration of the inauguration of the water system. And she's standing there with a tinaca is what they call the pot that's on her head. And that's the traditional water carrying vessel that they use in their communities to gather water. And then if you look a little bit on the right, on the water tank there, you can see obviously the EWB USA logo, but on the right, you can see that the community really took care. And I loved how they painted this and really made it their own. But you can see a woman on there also with the same pot on her head, kind of giving a nod to the old way of them collecting water. So this community reached out to us around the first quarter of 2020, sharing their need for clean water access. They had been getting their water from a nearby spring, but in around 2017, the volume at that spring began to decrease, and it eventually dried up. And then what the community had to do in lieu of that was to begin buying their water. So they would purchase bottled water, they would purchase water to bring into the community. And they reported to us that families were spending more than $11 a week to purchase water. So that might not sound like a lot to you or I, but for this community, it's quite a bit of money for them to just have access to water. This community has about 1,200 people. They speak a Mayan language. Their local language is called Cachiquel. And the name Chaquilla, it comes from two Mayan words. The first is Chaqui, which means scarcity, and Ya, which means water. So when you bring those two words together, the name of this community means water scarcity or no water. And I think that's kind of telling for this community. That's the name of their community. When we asked the community, you know, what are the changes that they want to see for their community? Why is this important to them? Some of the things that they told us is that they want their children to be healthier with clean water. They want their hygiene to improve, you know, being able to bathe and wash is really important to them. And they want their community to come together and be stronger, be more organized. And then the last thing that they shared was that they wanted, they were worried about the environment, the areas around their community because of deforestation. And so their hope was that they could, you know, reforest some of that area now that they had more access to water. So this project was done in partnership. So it's done in partnership with the local community. Not only this water committee that you see here, but the whole community was involved. We had the local government involved. We had local NGO partners on the ground. And then, of course, we had our volunteers. And through that partnership, we were able to complete a full water system for this community that serves 226 homes. And this was completed in February of last year. And so Maria is a community leader and a mother, as I mentioned. She's also part of the water committee, and that water committee is in charge of the maintenance and the operation of the entire system. So if you think about like when we get our water in the US, you know, we get a water bill, we pay that bill. Some of those funds are used to maintain the system, to make sure that the system is being kept up to date, repairs being made. And so that's what Maria does. She's part of the committee that is responsible for that. And I really am inspired by this community because of the water committee is very gender balanced. You can see there's 3 women leaders, which is really, really exciting for me to see. So I wanted to go to the next slide and play you a little video of an interview that we were able to do with Maria, and this was during the celebration. So we'll play this video and then, yeah, we can move on. So Natalie, are you able to play the video?
Ya lo cambió, o sea, ya lo cambió porque, como les decía, el vital líquido es el que me hace falta, a mí me hacía falta a mí. Ahora que ya tengo en la casa, ya, o sea, que ya puedo hacer otras necesidades porque no me preocupa del agua, porque a estos días, meses, es cuando se va el agua definitivamente. Entonces uno tiene que levantarse temprano o desvelar para agarrar un poquito de agua en la noche. Pero esto sí lo cambió, ya lo cambió mi total, o sea que ya es un menos compromiso de decir de que ¿qué voy a hacer? O me levanto o me acuesto tarde. Entonces ahora ya puedo descansar más. No solo yo, también las mujeres ya pueden descansar más. Ellas. ¿Y cómo lo va a cambiar en la vida en el futuro? Pues ya lo tengo asegurado, un vital líquido para mis nietos y para mis nietas. Entonces, gracias a ustedes, siempre no termino de decir de que esto es un gran apoyo que nos vino a satisfacer para la comunidad y a los 226.
Thanks, Natalie. So maybe just to end, you know, it's women like Maria that really inspire me to continue to want to do the work that I do. And so I just wanted to share that with you all, and I hope that she inspires you as well. With that, I'm going to hand it over to Brooke to share a little bit of a story here in the US.
Awesome. Thanks so much, Melissa, for sharing. And I have to say, it's stories like this that really inspire me and keep me in this work as well. But in my introduction, I mentioned that most of the work that I do at UWV is through our Community Engineering Core program, which is what we do here domestically in the United States. CE-Core provides pro bono civil engineering services to underserved communities that don't otherwise have the resources or funding to hire a local consultant to do this work for them. And so we do a broad range of projects at CECOR, not just water and wastewater, but a lot of the work that we are seeing is water and wastewater related, just due to some of the challenges we're seeing in the US in those numbers that I shared earlier. But what I want to share today is a story about a small community we partner with in South Carolina. And this is through our partnership with the U.S. Water Alliance, which is another national nonprofit organization that is working to increase water access in the U.S. And this community is a predominantly Black community and has a population of around 300 people, but it's been slowly declining since the 90s. I think in the 90s, they had a population of around 600. So just, you know, in that short period of time, they've halved their population. And this community was once thriving, and now they're facing a lot of economic challenges. The school, the police station, the library in this community have all closed within the last 15 years, due in large part to their lack of water infrastructure. So you can see some photos of the community here on the screen, but I really encourage you to think about your own community and how critical these establishments are and what that would mean for your community if you didn't have a library or a police station or somewhere to go to school. So just kind of setting the stage, but some of the challenges that this community face are with maintaining and owning their own drinking water and wastewater system that are both aging and in need of repairs. And over the last decade, they've received multiple violations from local regulatory agencies that have resulted in expensive fines in those different violations. And it's a really a managerial and financial burden for this community to maintain these resources. Again, it's a small community of only 300 people. But in addition to those drinking water and wastewater challenges, they also have high iron content in their water. This picture of the jar on the screen that you're seeing right now is water that comes out of their faucet. And so you can tell that there's sediment in there, it stains their clothing, it's forcing the residents to buy bottled water for drinking, which can be a really, expensive solution for them as well. And so there's a couple different challenges that they're up against. And what I really want to mention is that these challenges are not uncommon for many of the small rural communities that we work in across the US. And there are a lot of other folks who are facing really similar issues. So part of our technical assistance efforts that we're doing in this community involves community engagement and outreach events where we go to the community, we meet with them, we hear about their collective goals and priorities. And so this picture on the screen here, this Center of Life, is one of the only public buildings that they have in this community that's still open for people to come and gather. And at one of the community meetings that our partners held, they had almost a third of the community of 300 people show up, which is really amazing. And it shows that the people who live here are really actively engaged and want to participate in this process. And this really helps build trust within the community. So we're working with them and not for them. And it really is a partnership trying to lead these community-led designs. And part of the technical assistance that we're offering this community is to try and find funding opportunities for them to improve their infrastructure. And so we're working with them through a number of different federal loans and local loans to try and get access to hire a local consultant who can help them upgrade their wastewater treatment plant and upgrade their drinking water plant. But there really is a human element here. The story is about a community that is lacking basic infrastructure, but more than that, it's a story of the hope and resilience. And even though so many of the local businesses have closed, the community is very much alive. And their town slogan is a little town with a big heart. And I've definitely found this to be true every time I've been there and gotten to meet with community members. I had the pleasure of visiting early last year, and I met with some of the residents and with town officials, and the energy here, you can just feel it as soon as you walk into the community. But I sat down with Jackie, who is the town clerk and the town's only full-time employee, and she not classically trained in an engineering role, but really has taken the lead in, helping this community through those drinking water and wastewater challenges. And so she's a remarkable woman who's under a lot of stress managing these systems, but she remains optimistic and persistent towards helping her community reach those goals. So we're actively helping them pursue funding opportunities to improve their infrastructure. Part of that is exploring regionalization options with neighboring communities to help take away some of that administration burden and financial burden. But this community is is well on their way to receiving that support. And again, what I want to emphasize is that, you know, this community and this challenge that they're facing is not just about physical infrastructure, like new pipes or a pump for their well, but access to water in this case also means access to education, access to community growth, access to economic development, which really is the long-term goal of these residents. And I'll pass it off to Natalie, who will share another story with us.
Thanks, Brooke. It's great to see the work that we're doing all around the world. So for this next story I wanted to share with you, I really wanted to take us all to the really high mountains of Ecuador in the Ecuadorian Andes. So the Andes are taller than any mountains that we have here in the US. They definitely the tallest mountains that I've ever been in. And this is a small community of about 100 people, 28 homes that live within these mountain hillsides. And they're really, really steep hillsides. On the steep hillsides, there are potato crops growing. There are llamas, like you see in this picture, that are roaming the hillsides. And it's really just such a beautiful area. And these homes are scattered all throughout the hillside. So they're not really centralized. They're kind of scattered throughout the mountain. And this community name is Tingo Pucará. And this is how I got my start at EWB. So I visited this community as a student at the University of Pittsburgh back in 2011. And as I mentioned, the houses are scattered throughout the mountainside. And the way that this community had to get water was they had to walk all the way down this middle picture here, all the way down the mountain every single day to collect water out of a spring in these cisterns or these plastic containers. And then they would haul it all the way back up the mountain. It was about 1,000 feet in elevation. So a really long time. And they had to do this every day. And it most often fell on the role of women and children to do this. So we worked with this community to design a water system that collected that water at the bottom of the hill. It cleaned that water, it filtered it, and then it pumped it all the way up to the top of the mountain to a water tank, where then it got distributed to all of the houses. So every single house had a running tap at their home, right outside of their home. And, you know, rather than women and children spending hours a day fetching the water, they now could just turn on that tap and use it for their drinking water, for their irrigation, for their laundry, whatever they needed right there in their homes. So when I visited this community back in 2011, there were all of these little kids running around. The kids were helping us and helping build the system, and just really, really interested in learning what we were doing. And one of those little kids running around was a little 5-year-old girl. And you can see in the top right-hand corner here, she's one of these little girls who is sitting with the other women in the community and learning about the water system. This was a manual that we worked on with the community to educate them on how to work this water system and how to operate it. So one of those little girls was really interested in that picture there. And then fast forwarding 12 years later, a couple years ago, our staff went back to visit this community to check in on the community and check in on the water system. And our staff was sitting around the room with this community, the community leaders, and there was the Water Management Committee, which very similar to what Melissa explained in Guatemala. And sitting in that circle with our staff was a young woman who was a leader on that water committee. And we later learned that that young woman was one of those 5-year-olds running around and playing when I was there 12 years earlier. So one of those little girls in that top right picture. And now she was a leader in the community, really making sure that the community 12 years later still had that clean drinking water at their tap. And one thing that just really, really sticks with me and continues to inspire me is our CEO sat down with her after the meeting, and he said, you know, what's changed? What's changed over the years since this water system was installed? And she talked about how she remembered going down the hill to fetch water with her mom every day, but it's a distant memory. And she was very proud of her involvement in the success of the water system 12 years later, and said that she's excited that, you know, the future of her daughters don't have to experience spending all of that time fetching water. So just such a beautiful story of community resilience and the community coming together. And I picked this story to share because it personally just has a large impact on me, you know, not only to highlight the role of one little girl to a water leader in the community, but really this story had such a large impact on my life and on ultimately my career. I picked engineering in college when it came time to pick a degree because I liked math, but this community in particular put purpose behind engineering, and it really showed me that engineering is so much more than schoolwork and problem solving in math and science, and that it really is about the people. But yeah, we are excited to pass it back over to Lauren, and Lauren's going to lead us through a great discussion where we can share a little bit more about how we got to where we are in the STEM field.
Thank you guys for sharing. That was an amazing presentation and so impactful. The fact that she was a leader 12 years later, that's just such a really cool story. So now, I want you guys, if you had any questions during that wonderful presentation, please pop them in chat. But I really just want to start out with, and I'm just going to start with Melissa and ask you, like, what is your why? Why did you choose engineering? I know Natalie kind of touched on that with her story at the end, but I'd really love to hear from you. What drives you every day to wake up?
Yeah, thanks. I appreciate the question. So for me, I think it starts when I was very, very young. I'm half Filipino. My mom's from the Philippines, and that's where I was born and lived for the first 7 years of my life. And really during that time, I spent a lot of time with my cousins, my grandmother, my aunts and uncles. They all lived in a small village where my mom grew up, and they had no access to water or energy or sanitation. And so at a very young age, I saw sort of that disparity between like what we had where I lived in my home and what my cousins had or didn't have. And so that, I think, in my mind really, really stuck with me throughout my life and continues. I think about it still. It still inspires me, but it really like sparked my curiosity to try to understand like why this was the case in the world. Why is it that my cousin, we're related, and it was such a disparity. And I think that as I grew up and sort of was starting to think about what I wanted to do in college, similar to Natalie, I was pretty good at math. And being half Asian, my parents were very, encouraged me very much to study engineering or become a doctor or a lawyer. And when I thought about engineering, I saw a connection with maybe trying to help me sort of reconcile this disparity that I was seeing and experiencing. So that continues to inspire me. I always wanted to do sort of focus my work internationally. I worked as an engineer for a consulting firm for about 10 years when I graduated, doing a lot of engineering, technical design work like pump stations, designing water systems, sewer systems, doing stormwater design. And it was around 2008, so about 10 or 11 years into my career, that I decided to make a shift to try to do international development work. And the way that I did that was by joining the Peace Corps. So I was a Peace Corps volunteer for 2 years in the northern coast of Peru. And that's actually where I learned about EWB USA and started as a volunteer, a little similar to Natalie. I wasn't a student, I was a professional when I was a volunteer, but you know, I was so inspired by the group. The group that I was supporting, it was a chapter out of Princeton, and the work that they were doing. And we worked on a very similar project to what Natalie described, but this was in Peru, but a similar, very small community, about 15 families, very high rural area. And it just like, I knew that that's what I wanted to do going forward. So that's, and then what continues to inspire me today. Obviously, I think our volunteers are super inspiring to me. The amount of dedication, passion, curiosity is so inspiring to me. And then the leaders that I get to meet and engage with and see, the community leaders, but also local NGO partner leaders as well. So yeah, that was a long answer. Apologize.
No, that was perfect. That's exactly what we're looking for. And then Brooke, I'm going to toss you the same question. You know, what is your why? What really drives you every day? What started you along this path?
Yeah, awesome. Thanks for that question. And I think similar to Melissa, my motivation really kind of started at a young age. And it started with water, actually. So I think growing up in the Midwest region near the Great Lakes, water has always been such a big part of my life. And there were times that I took that for granted that I live nearby to one of the world's largest sources of fresh water. And it was just, you know, something I felt really passionate about, protecting water quality. And then I think from that age, I knew I wanted to work in the environmental sector, specifically with water, but there were a lot of different pathways to do that. I could have gone into environmental science or chemistry or all these different things. But I think what really drew me to engineering, or what really kind of pulled me in, is that I felt like as an engineer, I would have the technical skills to really think about solutions to these problems I was learning so much about. And so, you know, what can I do to try and solve those? How can I work with other partners? Really kind of that technical knowledge that allowed me to think critically about these problems and how we might be able to solve those. And so I kind of chose to go the engineering route because I knew I wanted to make an impact in the water space. And so I pursued a degree of environmental and ecological engineering at Purdue. And it was here through a volunteer organization similar to EWB, but not EWB specifically, that I started to understand the human element of engineering while working with water. And I was working on a project internationally in Haiti, water distribution, you know, similar to the story that Natalie shared as well, and just really saw the impact that it had on this community. Something as simple as, you know, having, you know, tap water to something we take for granted. And so working with real people, seeing firsthand the impact, it really was my motivation to keep going. Otherwise, I don't think I would have stuck with it. I think, you know, I wanted to do things like that and not just sit in front of my computer or do technical designs. But after I graduated, I took more of a traditional civil engineering role. And I worked in that space for about 8 years before I switched over to nonprofit. And there I was working on sustainable site development, as I mentioned, some green infrastructure and stormwater components. And I really loved that technical aspect of what I was doing, but I had no connection with the people I was working for, essentially, or the communities that were using the spaces I was helping design, or would be interacting with nature in this environment that I was creating. And so I really felt like I was missing that human element. And so that's kind of what pushed me to explore some other options, and this opportunity at EWB came up, and it's been, you know, an amazing experience. And I think, you know, with some background in working internationally, I think just, you know, throughout the last like 5 years or so, just really understanding the water challenges that we're seeing here in the United States as well kind of encouraged me to get involved with the Community Engineering Corps program specifically. And, you know, we have people in our community or our neighbors or people in the county next to you who are struggling with these things too. And so, you know, what can we do to make an impact here in our backyard as well? And so that's really what motivates me to keep going, is that I'm just so inspired by the people I work with, like the story I shared earlier about Lee County. I think their strength and resilience is really beautiful, and it reminds me every day why this work is so meaningful.
Thank you so much. And then Natalie, we're going to toss it back to you. What is your why, and what drove you to engineering?
Yeah, thanks, Lauren. And I started touching on this with my story a little bit. So similar to Brooke and Melissa, I grew up around a lot of construction. So my dad was a construction worker. And as a kid, I was always just really fascinated seeing everything come together from nothing and building something from the ground up. So I think that was always in the back of my mind. But when it came time to sit down and pick a college and pick a career, I was a first generation college student, and my parents didn't really have much to offer in terms of, helping me with that career path. And so I knew that I was good at math and I liked math. And I heard, probably through STEM outreach things in high school that engineering might be a good pathway for me. So I chose engineering when it came time to decide a discipline my freshman year, but I really wasn't quite sure what that meant for me at that time. At that time, it was a lot of math classes, a lot of science classes, and I wasn't sure exactly what my future was going to look like. And then I mentioned my experience with EWB as a volunteer. So it was really that project and my experience that opened my eyes to the world of engineering. And that really showed me the impact that engineering has on the quality of life for people all around the world. It's a lot more, like I mentioned, than just schoolwork and problems, but it's real people that are being impacted by the work that we are doing every day. So after graduating, I actually went into the construction industry for about 6 years. I built a really large hotel in Washington, D.C. I had a lot of fun doing it. I learned a lot about problem solving and engineering, but I learned a lot about myself during that time. I learned what it meant to be a female in a male-dominated industry, especially in construction. Oftentimes, I was not only the only female engineer, but the only female on the job site, which I learned a lot about how to navigate that and how to really stand out as a female in the industry. And then in addition to gathering all those, engineering and problem solving skill sets, I really learned that this work is more about the soft skills. It's about communication and people management and connection. And that is really what I enjoyed most about the job. And that's really what kept me going back to that experience as a volunteer in college at EWB, thinking about the soft side of engineering, the soft skills of engineering, and the human side of things. So I think that it was that project that really helped define my why, which was the people. My purpose in engineering was to use my skill sets to directly improve the quality of life of others. And what kind of really honed that in for me is when I was in that interim period where I was working in construction, the CEO of Engineers Without Borders at that time hosted something called a AMA, or Ask Me Anything. I don't know if you guys know what that is, but it's essentially like what's on Instagram now, where like the influencers will have the little box, like ask me any question, and then they'll answer it. So that's what it was, but it was not on Instagram. So the CEO had that, and I was, in this position where I really enjoyed my career, but it felt like it was lacking that human connection. And I asked her the question, I said, how does an aspiring engineer get to a position like yours, the CEO of an engineering nonprofit? And her response always sticks with me. She said, 1, find something that you're good at, and 2, find something that you're passionate about, and find what's in between those two. And for me, it was that engineering with empathy piece. So I knew that I was good at engineering, but I was passionate about the human connection and seeing people thrive. And that's really my why. That's where I got to where I am today, and what continues to inspire me to do this work and will continue to inspire me for a really long time.
That's amazing. Thank you so much for sharing that. So we have about 10 minutes left in the session, and really I want to point out how wonderful these students have been. They have designed some really, really creative and with ingenuity solutions to our lab. And so I want to ask the three of you, some of them are seniors, some of them are freshmen in high school, not even thinking about college, but what is the piece of lasting advice that you would really want to give to these high schoolers who are just trying to figure out what they're doing next and what they're interested in, what they're passionate about even. So we'll start with you, Melissa. What would you like to leave these students with?
Yeah, I think I would say understand, figure out what drives you, what motivates you, and try to go for that. I mean, I think if it's people that motivate you, there's opportunities. I think anywhere in the STEM industry, there's opportunities for you to grow once you figure out, what it is that motivates you and drives you. And I think for figuring out, your personal why, what is the change that you want to see in this world and how can you contribute to that? I think that's so important. And if you can figure that piece out, then I think it becomes easier to figure out the pathway to get there. So that's what I would say.
All right, Brooke, you're up next.
Yeah, I think really similar to what Melissa just said, like find what you're passionate about, find what you're good at. And I think that the way you do that is just by trying a lot of things and going for it and really kind of exploring your interests and moving forward with a lot of those things. I'll say like when I was a college student, I had a number of different internships in different water related fields, and I did a couple jobs that I learned that I didn't really like that much. And so just by like going out there, having that experience, putting myself in that situation, I learned what I really valued and what I was good at and what, I didn't want out of my career too. So I really encourage you guys, if you think that you might like something, to really go for it and try it. And if you don't end up liking it or it's not a good fit for you, it's not a waste of time. At least, you found, some more direction in that. So that's what I would encourage you all to do.
All right. And Natalie, what do you have to add?
Yeah, I would just echo that. It's okay to not know what you want to do, especially right now. And the beautiful thing about the STEM field and really any industry is it is so versatile. There are so many options out there. You never have to get stuck into a box. I graduated with civil engineering, and while I'm doing some of that now, I'm doing above and beyond that and a lot more of the human management and people management side of things. So really just to echo what Brooke said, soak up all of the opportunities that are out there for you. It'll really help you to learn what it is that you are interested in and what does motivate you and what inspires you. And then really that intersection that I mentioned of, what it is that you're good at and what it is that you're passionate about. But it's okay to not know what those two things are right now. Really, give yourself some grace and allow yourself some time to try out some opportunities to really figure that out.
Thank you guys so much for your insight. I think this panel has been such a huge success and so insightful and so inspiring to listen to. I feel very inspired after listening to all of your guys' stories. So unless there are any further questions, and you guys still have 4 minutes to put your questions in chat if there are any further questions, but I will hand the session back over to Jillian so she can close it out.
Thank you so much. I don't know about you all. My mind is just blown and inspired. And can we please, I know we can't hear each other, but can we give a round of applause like for Melissa, Natalie, Brooke, and Lauren? And I have to say, I know it can feel like a male-dominated field, but I hope that the young ladies on the call really got some inspiration from the gems that were shared with us today. So again, thank you, Melissa, Natalie, Brooke, Lauren, you did an amazing job leading today's event. Thank you so much. Thank you to the ET staff that put in work to make this happen and for being here. But most importantly, thank you, teachers and students. Students, thank your teachers. Thank you for being here, for working hard. And we want you guys to know that you all can go on to do great things, just like Melissa and Natalie and Brooke and everyone on this call, okay? Hope you join us for our next event. January.
Thank you.
Hey, Pilgrim, you're welcome. Our next event, January 21st for robotics. Hope you join us. Don't even need kits. Please submit those exit tickets and look out for an email from Jen with the full recording of today's event. Okay, thank you, thank you, thank you. Enjoy the rest of your day. See you soon.